Thank you for attending. Let me present myself. Then Cengiz Ari. I'm the program manager for the U-space, VLD, and industrial research project within SESAR. A few words about the demonstration. Then we have 6 very large demonstration projects, then VLD, we call them VLD. Those are projects for 2 years. They started 2 years ago. They are finishing for the moment. Some of them finishing in September. Some of them have requested an extension. But all of them in the 2-3 months will be finished. What is the focus of those projects? We ask those projects to say, okay, guys, during the exploratory research, you let some drones fly, 1 or 2. Here, we would like to go to a larger scale. Please do a lot of demonstration. Without mathematics, values, figures, data, we cannot have enough evidence to go to the next steps. This is what we asked those VLD to do, and this is exactly what they did. You see, in fact, the number of demonstration sites those projects did, and knowing that in one site they can do multiple projects, multiple exercises, multiple use cases. That means that it's not 1 or 2 evidence that we have. It's not only 1 or 2 or 3 demonstrations. It's close to, I think, 39 sites where the project has been executed, at least. The results of those projects, lots of them are successfully executed. Very good results, very impressive demonstration. Multiple open days have been organized where we invited people to attend and see real drone flights. Unfortunately, some difficulties. I don't know if they will mention that during their presentation, but some difficulties to obtain the right authorization. Okay, difficult, but not impossible, they will say. A lot of drones have been flown. Some technical issues happens. If you don't fly, you don't break. But at the end, a lot of data, a lot of execution, hours and hours of flights. That is, let's say, the basis of the results that we expected from those projects. What do we do now with those results? All those results are documented in documentation that we call demo reports. As those projects are funded by the public money, European Commission, SESAR, the majority of the documentation, not all documentation are public. They will be published on our sites. You can go and consult them, have also the evidence and the data. This is one step. Second step, we ask those projects also to document, let's say, recommendation for standardization, recommendation for regulation. And all those inputs, all those data, all those evidence are going in what I call a loop. We transfer them to our colleagues of the standardization bodies. We share them with our regulation colleagues from EASA. And this is, let's say, for them the input. Again, I use the third time the word evidence for them to say, voilà, based on this, can we adapt, improve, fine-tune the regulation or the standards? Not having this loop will lead to a statu quo. Having those results now, hope that in the next phase of the batch of regulation, next phase of batch of standardization, regulation will be improved, standardization will be set in place. Last elements I wanted to share with you that we invited a lot of projects. Some of the project colleagues are not present here today, unfortunately. Why? Because the demonstrations are still ongoing. This week, today, I think that we have 3 demos ongoing in parallel. One in Germany. I think that Andrew will give a word on that. We have 2 projects also being executed, one in Budapest and one in Bari. Then I'm thinking to those colleagues who, despite all this event, are working hard to make those projects a success. I will not spend too much time. I will not take too much of your time because, in fact, the star of the day is not me, it's the other projects, other project coordinators that are spending day and night to make those projects a success. Then I would like to first invite the first project to the scene. Then Pablo Menendez, who is leading the project Amulet. He's a project leader and software system engineer with more than 14 years of experience in ATM, in U-space software system engineering projects. He's an expert in tracking, and currently he's the project coordinator of Amulet, the VLD Amulet, and product manager of Airus, which is the first independent Spanish U-space platform. Please welcome my colleague, Pablo.
Thank you, Cengiz. Yeah, so I'm project coordinator of Amulet. Amulet is a very large demonstrator, as Cengiz has just introduced. I'm part of entity data. Here, you've got the consortium, the composition of the consortium. We play the role in this project of coordinating it and also doing the communication, dissemination, and exploitation. We also have NLR in the consortium. They play an important role in this project. They are the technical coordinators of it. They also coordinate the demonstrations. We planned and executed demonstrations in 3 countries. They coordinated the whole setup for them. But then we had specific partners coordinating the different clusters or the different countries' demonstrations. The first one is Cranfield University. They coordinated the demonstrations in the UK. Then NLR coordinated the specific demonstrations in 3 sites in the Netherlands. And then ITG, the Technological Institute of Technology in Galicia, coordinated the demonstrations in Spain, in particular in Santiago de Compostela. Then we also had Boeing. Boeing is in charge of the development of the concept of operations. We had INECO. They did the technical specification of the whole the design, how everything was going to be integrated and what was technically needed in order to execute the demonstrations. We also had ANDRA Technologies. They were a USSP in the project, but they also did the integration of the technology, the actual integration, the actual definition of the ICDs. We also have Airbus. Airbus is in charge of the standardization and regulation, mainly. But we also have other partners on board. We have Tecnalia. Tecnalia integrated their vehicle and operated it. We also, in the vehicle side, we also have EHang. EHang, the similar thing. They integrated their vehicle and operated the vehicle in the different sites. It wasn't possible to operate it in everywhere, but we'll get to that later. But we were able to fly 2 of the vehicles, and that was really important, and thanks to Tecnalia and EHang for that. Then we have CATEC. They operated and integrated their fleet of drones in different sites. Also, the GMT Amsterdam, the Council of Amsterdam, they were part of the public acceptance analysis. JEPESEN also, as part of the standardization and regulation package. We have also Altitude Angel. They were USSPs in the project. Space 53 operators and technology integrators. AirHub also operators. And ENAIRE, the Spanish ANSP, had a really important role in the project by providing operational use case with ATCOs and demonstrating the dynamic reconfiguration of the airspace. We had several objectives, but to summarize, we wanted to create a high-level concept of operations. We needed to have a base for the demonstrations, so we needed to develop the concept of operations, and of course on top of what was already there. We wanted to demonstrate the safe integration of UAM into U-space with all the U-space users and the safe flight of UAM. So we defined a set of actions in order to achieve those objectives. Of course, to generate a high-level concept of operations that we were discussing yesterday, to define use cases for the demonstrations, to carry out a safety analysis. We wanted to test different U-space architectures centralized and decentralized, where in the centralized, the CIS, there was a CIS with a core role, and in the decentralized architecture, we wanted to test the inter-USS protocol. So that was kind of an objective also for the project. Then we needed to implement the technical solution to actually integrate because it's hard to integrate. It's harder. We found indeed that it's harder to integrate USSPs than we expected because we didn't have standards. We needed to explore what standards we could use, what we would need to develop that wasn't there. So it was quite a challenge. But we succeeded integrating USSP, so that was really good. And then, of course, to perform the flight demonstration campaigns, to disseminate the project outcomes, and to provide the input to standardization and regulation. Moving into the achievements, these, as a very large demonstrator, initially for us was something, the initial idea was, okay, we need to demonstrate that technology is on this TRL level, and that was like a target for us. And it was all about demonstrating that that was that way. But then we found out that instead of just being a demonstration of that very TRL level fact, it was like a journey of discovery. We discovered that we were demonstrating many things, and we were also finding out the TRL level of many other things. And indeed, the important thing of a project was not if the TRL level was 7, and if not, then we didn't succeed or something like that. No, the important thing was the discovery process, the discovering where we were. So, because the word demonstration is kind of confusing, because maybe it sounds like you know what you want to demonstrate, but in this case, we didn't know. So I better use the word validation or discovery. So that was kind of an interesting process. But as results, as you can see there, it's like a very dense slide, but we've compiled results in testing U-space architectures. We tested the centralized, as I said before, and the decentralized. We had 4 USSPs, up to 3 working simultaneously integrated among each other. Then we also had 3 CISPs, different CISP softwares, 3 ANSPs participating, and vertiboards. We also tested the initial testing of integration of vertiboards. Then, of course, the UAM flight demonstrations. That was a result. Also, we flew eVTOLs. We couldn't fly them in an urban environment. We initially wanted to fly them in an urban environment, but that turned out to be really challenging in terms of authorizations. So we decided that instead of just giving out, why not fly in a simpler place, and let's discover what the problems are offline. But at least we were able to fly. So I think it was quite an achievement, and we're really happy with it. We also integrated with ATC. We had a use case where ATC played an active role in the demonstration. We tested the dynamic reconfiguration concept in Spain. It was really interesting. The concept of Spain was like trying to ease the process of quickly dynamically reconfigure the airspace for the ATCO with an easy to handle interface. That was really interesting. We tested also contingency management in ground field, the integration of HEMS, and we did demonstrations in 6 locations and setups. Different setups for the locations in the UK, Netherlands, and Spain, as I said before. And then also as a result is the technical solution. We produced material on technical solution, which is really interesting to read. As we decided on operational models, we even created some of the models. The U-space architectures, you have them for your reference. We decided on which standards were best or which standards we needed in the different architectures. And we also developed data flows. So that's quite an interesting output. We also developed the high-level ConOps, as we were discussing yesterday in the CCC session. We developed a layer airspace structure as a way of segregating traffic, separating between standard, what we defined as a standard performance traffic and high performance traffic, where air taxis or these big vehicles would be using or in the category of high performance vehicles. We developed in this high-level ConOps a notional architecture with roles and responsibilities. The adaptation of U-space services to vertiports, the integration of manned aircraft. So reading our ConOps is an interesting read, and yeah, an interesting result too. We developed also use cases. We had 14 representative mission types, combining nominal scenarios, vertiport and in-flight scenarios, as well as control and uncontrolled scenarios. We had combinations of all those things. Also in terms of social acceptance, we had focus groups in 3 different countries. We surveyed around 2,500 people, and we are currently developing recommendations per demographic group. Standardization and regulation is the other result, and also communication, dissemination, exploitation. We've been in a widespread news dissemination. We've been in the news many times as Amulet. We had 3 open days, 5 demo days, 2 advisory board workshops. Well, you've got the figures there. And the standardization and regulation, we are actively working on it now to finalize it. But it's also a very good output. So you can visit our stand, you can get in-depth knowledge with the technicians around. We are over there. Also, we have a website to get more information, or you can write to us in the email. We are also on LinkedIn and Twitter. So that's it. Thank you very much.
Okay, thank you, Pablo. Next project, which is the Chorus X UAM, which is one of the most important projects, which is a flagship with Andrew Atley, who is with Eurocontrol for nearly 30 years. He's also the architect and the writer of the ConOps edition 3.0, and for the moment is building the 4.0 that we will explain later on. But in the meantime, he will present the outputs of the Chorus X UAM demonstration project.
Thank you, Cengiz. I'm here in place of Giancarlo Ferrara, who is the project lead. Giancarlo is today in Kokstad, where one of our demonstrations is taking place. So we should be flying right now, I hope, if the weather permits. Chorus X UAM is a bit of a kind of collision of 2 projects. We were looking for an opportunity to continue the work on the Chorus concept of operations, and we felt that the best way to do this was to combine that activity in a very large demonstration. We have 30 organizations involved, 19 as project partners, 11 as linked third parties, some of whom have their main interest in the ConOps activity, and the others are divided into little clusters who between them have organized 6 demonstrations. Now, if you look on that little map, we have made a composite view of a city where we have put the 6 different activities of the 6 demonstrations. I should have produced just a map of Europe, but this one kind of shows thematically what we were up to. The example which I'm going to talk about in some detail was the operations in Spain, where we were flying above a beach area, doing urban delivery, but in order to get permission to fly, it was more on the beach, but it was just at the edge of town, so it was kind of urban-ish. We also have been doing, today we are flying in Germany. We are flying in a safe area, and the flights will be transformed by magic to appear to be a flight between Frankfurt Airport and Frankfurt Mess. We will also be flying at the same site a flight which simulates a flight from Heathrow to London City Airport. So with the involvement of the German partners and the British partners, we will have the UTM system in the urban setting, but the volocopter will be flying in a safe environment. We would have liked to have permission to fly over Frankfurt, but as Pablo mentioned, these VLDs have been hamstrung by the difficulty to get permission to fly. The Belgian VLD, which was shown here in the harbor area, we were flying first response and observation missions in a harbor area. We had some particular difficulties. The flight itself, when it takes place, will be a state flight. Demonstrating a state flight doesn't count as a state flight, it counts as a civil flight. So the kind of things we would have permission to do as a state flight, we do not have permission to do as a civil flight, so we required an enormous closed airspace. So it's been a learning process about getting permission, and for following work, I would suggest focus on getting permission. Have your permission before you start writing software. The other demonstrations that we have done variously, we're doing urban work. In Italy, we flew from a large airport to a very small airport. We transferred some vaccine to a small UAS, which flew to a hospital. There's a stand over there with a film about that demonstration, which I would encourage you to have a look at and talk to my Italian colleagues. So it's been a huge project. We have learned a lot. In September, I went to Pontoise on the north of Paris, where we were doing a demonstration of volocopter and pipistrelle flying with small UAS, deconflicted by U-space. And they talked at length about how much they had learned. The difference between having an idea and actually implementing something is where the money has gone in these projects, but it's where the value has come. We have learned so much from actually trying to get things to work and show the aircraft flying. And I can't state enough the importance of these very large demonstrations in progressing the SESAR work towards deployment. The formal report that we write at the end of the project, the really interesting stuff are the little bits about what went wrong and how we had to fix them. In Spain, on the testing day, nothing worked. And the team from UPC, Enric Pastor, stayed up all night writing software to hack the surveillance so that we could have some situational awareness. The next morning, everything was working. So a very important learning process, some anxiety, but as they say, we will laugh about it tomorrow. But it's been a very useful project in terms of maturing ideas. At the same time, conceptual stuff has been developed, which has been fed back. And I focus a little bit here on the Spanish VLD because it was the first one we performed, so it is most in position to talk about their results. Spanish VLD was executed on the beach at Castelldefels, which is in front of Barcelona Airport. It's actually underneath the approach. The flight involved local actors. We had the police, we had the council were there, but the police were flying. We had 2 different U-space service providers. We had CISC. We had the full Spanish implementation. Enrique told me that to get permission to fly there took 5 months of negotiation with 10 different authorities. Eventually we did 3 or 4 days of flying, and what did we learn? We established an airspace structure. This is not something imposed by the U-space ConOps, but it's something which is enabled by it. So we set up these corridors. We had 2 corridors in each direction, and this greatly simplified the job of deconflicting the traffic. They would fly on one, and if that was occupied, fly on the other. We could also use it for contingency. Next. This corridor structure worked well in this case. We were delivering to various points on the beach. We were doing ad hoc missions. We were doing simulated contingencies, and then we had an unsimulated contingency. So it was a very interesting 3 days of exercise, and then a 4th day when we did a demonstration, public demonstration. So we were doing 20 flights per hour. It was quite a busy exercise, quite a few drones flying simultaneously, the different U-space service providers interconnected. So here's a little picture of the distributed airspace structure, U-space structure, how we had the different systems connected. And in the strategic deconfliction, we ended up giving the aircraft 2-minute windows to take off. We didn't give them a fixed starting time. We took account of the uncertainty in their ability to connect the battery and get the thing launched and so on. So we were giving these 2-minute time slots, and we deconflicted the flights that way. So overall, we achieved a reasonable amount of flying, and it seemed to work, but at the same time, UPC were involved in collecting the reactions of the public. We were asking passers-by what they thought. We were measuring the amount of noise that was being made, and so we attempted to get the whole picture about how well was this working, how acceptable was it, and this will all find its way into the demonstration report, which you should be able to pick up in due time. So we ended up building this operation support platform, which is not something which is normally found in the U-space architecture, which was a system for distributing the surveillance information which was coming through MQTT, so Internet of Things protocols, and we had this central point that was redistributing it. One of the factors which bit us and will probably bite other implementations are these questions about the session. If you have a plan, you have a flight registration, an aircraft registration, but eventually you need to associate that with a flight number or a flight instance. You need to associate that with a tracking device, which might have a different identity, and you need to pull all these together. And this operation support platform was the place where all of these different identities for the same flight were being combined. This should eventually become part of the front end of the U-space service provider in a standardized architecture. I'll skip over some of these. I got a bit too much here and time is running out. So if you want to find out more about the project, we have a website. I would encourage you to go to the stand, talk to my colleagues. We have a list of interested parties. We will contact you in due time, tell you that the result is available. So yeah, don't hesitate to keep in touch. Thank you very much.
Thank you, Andrew, for the presentation. Nice presentation. Next project to come on scene is GOV2. GOV2, which is, stands for Gulf of Finland, which is a continuation of a project that was executed in the first batch of projects. I invite to the scene Maria Tam. She's a project manager at the Estonian Air Navigation Service, and it's involved national implementation of U-space in Estonia. She's also leading the coordination of GOV2, Integrated Urban Airspace VLD at JANS. Please welcome.
Thank you. Hello, everyone. So, yep, Gulf of Finland 2.0 integrated urban airspace. So we have altogether a consortium of 15 partners, and each consortium member really has a role as a U-space stakeholder in doing really important tasks. We have 3 ANSPs, various technology providers in the consortium, also operators, drone manufacturers, as well as weather information and network connectivity information providers. We focus on business and technology exploitation, and also, of course, creating a simulated environment for our validations. So altogether, indeed, 15 members from various countries worked 2 years now to provide all the lessons learned from this project. What were GOV2's objectives? I would like to stress the most important objective, to really demonstrate combined UAS, eVTOL, and manned operations in unified dense urban airspace with current ATM and U-space solutions at hand. So we are taking the real-life situation and trying to see how the current solutions support these expectations. We demonstrated the operational and regulatory acceptability. In addition, we demonstrated 4D data quality and availability to really accelerate flight approval process and getting access to airspace and do the flights. We also evaluated the potential for technical and operational and economical scalability for GOV2 system of systems. And in that, we went and integrated the GOV2 solution with third-party partners to see how it all works. And of course, we wanted to see how the U-space capabilities and services today really support the operational expectations of various stakeholders. So here is our validation approach. Altogether, we had 4 types of trials, and each served a specific purpose where we operated in different environments. So we had trial 1 with large number of mixed operations in CTR. We made flights in CTR in the vicinity of airports and other critical infrastructure. We had trial 2 where we explored the peri-urban setting where we enter and leave the airspaces and CTR. Our focus was also on cross-border flights, and this is also something that we really looked into, how we can do international flights. And as I mentioned previously, the scalability objective, we also had trial 4 as a roadshow trial to validate international scalability. These trials we also validated in 2 waves of operations. So the first wave was really setting up the technical infrastructure and getting the hang of integration that we intended with our solution. In the second wave, we really focused on validating the full capability of the GOV2 solution to see how it really works. And when in wave 1, everything was really planned to the last detail, in wave 2, we really wanted to see how much can we really rely on the systems while we are operating. And in that regard, we used this creative approach where the whole plan was only known for the trial lead and the safety manager, and everybody, the operators, just had their mission information, and we really stress tested the system to see how it works. In between these waves, we took the GovII solution and went to other countries who were not part of the integration process during the project, and we saw how easy is to integrate the GovII solution, taking the CNS information, taking the AIM information, and setting the GovII solution up for third-party members to fly and operate during the trials. And this was to really explore how scalable what we have worked on is outside the consortium. We defined UAM use cases, the standard use cases, what we foresee are part of the UAM ecosystem today. We had delivery operations, we had infrastructure surveillance operations, mapping, but also if we consider the urban setting, there could be occasional tourist flights happening. We could encounter HEMS flights. If we fly near the, in the vicinity of airport, we should consider also the inbound and outbound traffic from the airport. And of course, we had eVTOL flights in different scenarios. And we took these scenarios as basis, and within the trials, we validated a combination of selected scenarios that reflected this operational environment the best. So we implemented the multi-stakeholder architecture, the GovII solution. This architecture was based on the principles of SJU architecture, the concept of operations from Chorus, from the current regulation. And what GovII focused on was really integrating all these stakeholders together to share data in U-space. And as a result, we delivered the information exchange services. These information exchange services really enable the technical integration of stakeholders, how they share information, and it was really not dependent on what type of a stakeholder you are. You are involved and you have access to the U-space in the same way, with the same logic. So here we have the set of services that we described together with data models, and we hope that these outcomes from GovII really facilitate creating interoperable and scalable U-space implementation. Additionally, what we worked on, we proposed also a new capability, a multi-stakeholder approval. So in some areas, you need your flights and operations need to be approved by various authorities. Let's say you are in the CTR but want to fly in the port area, and you need to approve your flight also with the port authority in addition to ATC. So you need a tool to do that. You need something that supports that. In GovII, we implemented the multi-stakeholder approval process in cross-border operations, because international flight between two countries, it requires approval of operations from both sides. In addition, also, we implemented the segmentation of operation plans. And the logic was that only the takeoff and landing operation plan volume segments reached the ground. This way, we cleared up a lot of airspace so that flights and UAS operations can happen simultaneously in the same location. And of course, it uses the safety buffers around the operation plan. But again, this enabled and allowed other flight trajectories to route it under and above other operation plans. And the final or main outcomes and take-home messages from the Gov 2.0 project. So we really see that the scalable interoperability across Europe requires standardized information exchange services. This enables all types of stakeholders to really integrate to U-space and share data. Also, there needs to be an efficient use of airspace for mixed operations, especially in the CTR. And where ATC coordination is required, they need to be able to directly interact with U-space, but only on a must-know exception basis. And also, what we want to stress is that the integration between USSP and UAS fleet management systems is as important as other integrations within U-space. And this will provide a much more safer way and more efficient way for UAS operations. So thank you. If you have any more questions, you can always approach the project team at our stand back there or visit, of course, our social media and homepage. Thank you.
Thank you, Maria, for the presentation. For the next project, which is SAFIR-MED, I will invite Michael Shamim, who is the CEO of Helicus. He was a coordinator of a lead healthcare hospital group in his previous life. He's always interested with aviation. He's holding a PPL and any drone license that he could get his hand on. In 2016, Michael launched the Helicus with the aim of making ad hoc and rapid drone-based service a reality, which is what he's doing with these projects, and also one of the driving forces behind a growing multi-sectoral ecosystem that drives SAFIR projects to achieve this dream, not only for a technical, but also from a legislative point of view. Then please, Michael.
Thank you, Genesis, for the nice words. I like the enthusiasm that you radiate. That indeed is what is needed, I think, in all of our sector. And it's an honor to be together with you all again. Yeah, there's already some images of what we've been doing in the SAFIR-MED project. And the key point is that we're one team, right? So here we have the full team together, 17 partners from 8 EU member states. And also, not without importance, 12 advisory board members, many of, let's say, from an international organization. And it's this team together that I think, together with, and similar to what the other projects also did, created quite some remarkable activities and results. And I'll maybe just keep it to an image. So basically, of course, SAFIR-MED, the MED stands for the medical use cases that we, let's say, used as the basis for all the technological and legislative activities that we deployed. So as an example, from a hospital to, let's say, medical technical organization, we of course want to do and execute a flight. We want to do a transport, so it's all about this red dart that we want to fly. For that, of course, we need someone to take the responsibility, the operator, the aviation company, the airliner, which needs some technical capability, a command and control center to receive an order, and to obtain then also the authorizations and all the information required to be able to execute a safe flight. And of course, there are some other users of the air already since 100 years there, demand aviation. So also there, a big concern, okay, how to interact with those. And then finally, we have a series of missions. So we also have a series of technical capabilities required in the air. So the 5 drone partners, actually, we had 5 manufacturers part of the project that executed the flights. And all of them were also digitally interfaced with the command and control center. So the full flow was actually interfaced. And that was for us all quite an important step. And we, let's say, did that together with other manned aviation in the air when we did the demonstrations, as well as we did advanced simulations to look at, okay, what capacity is actually available in the air and relative to several let's say, restraints. And then, okay, finally, we have to, of course, close down the flight. So the key point, this one team, you see that indeed we have here the several types of partners. So on the command and control center, we have Helicus, which is the operator, NSX, which has the technology, the software that drives it, Agentfly, that connects and does all the simulations at that level. Then we have at the air traffic management level, we have, of course, our air navigation service provider, Sky is there, with then two USSP, so U-space service providers, Skydrone and Dronic, active with their systems that are also powered by Unifly and Involi on the, let's say, the data provisioning side, supporting conspicuity. The next level of partners are then, let's say, developing technologies and the from the manufacturer side. We had TU Delft on the AED drone, Sapka on the drone you just saw in the movie, HiFly, our hydrogen VTOL, FlexDrive, let's say, tilt wing VTOL, and then Yang, our passenger drone partner. And then finally, we had supporting activities around communication, future needs around, you see on, let's say, supporting concepts, RWTH as university partner, and Stad-Aachen as one of the cities where we are still trying to get, let's say, the permission to fly to what we intended to have. And then we have, of course, very importantly, the various advisory board members reflecting all the different constituency partners that we had to have in place, from both the medical, let's say, aviation, so we have the Red Cross, EASA, Eurocontrol, Baloise from an insurance point, Proximus from connectivity. So this was, of course, and I think we all experienced it, the connectivity is really a key anchoring point to have a safe setup. We have hospitals, cities, ports, and also some university and research partners. I should not do too much. Actually here, I just mapped the same figure with all the partners. So just to show not only how complex it is, the full thing, but also that we really covered all the different areas with the matching. This was our work plan, what we did. And maybe without going too much in details on the work package 1, we actually, as to requirements, architecture, and use case scenarios, we really applied real life requirements into this project. And we did try to simplify as much as possible this setup to a simple project setup. So that's why we had this, let's say, all our demonstrations were always using the same setup. So that's why we typically refer to one team, because we're all working together. Work package 2 on the use-based services and the CONOPS per location. There we indeed tried to identify some improvements that we could find for the CONOPS. And actually, yesterday morning, we indeed got confirmed by Andrew that actually, I think 5 of our improvements were actually included in the CONOPS. So we're actually quite. Yeah, will be included. So we're actually proud on that, because I think that's also the purpose of why we do these things, that we build on the knowledge, and that it's not only like, an independent activity, but we actually feed it in, and in the next steps of our industry, we get those to put in place. And it's not only like, oh, cool, we did these things, but we really built. We provide some building blocks that other projects like Core 6RAM can then really use. So and thanks for that, Andrew, to coordinate all these elements and bring them together, because we all tend to go in all our different directions, but to bring them together, I think that's quite a challenge. So thanks for that. On the, let's say, we, of course, on the infrastructure adaptation demonstration part, that was not a little thing. So we created all these interfaces that I referred to. So all partners are actually digitally interfaced, both towards 2 USSPs, but also towards 5 manufacturers. So that was quite a feat. On the use case demonstration and the technical readiness level validation, there we actually did flights between hospitals and other human material. Actually, that was another project, but we use actually our SEFREMET setup to do that. So without SEFREMET, it would not have been possible. So this is really critical for the medical sector that we show them as well that we really are able to do so. Yeah? And up till now, actually, this was not really done, as we can see a bit later in, let's say, an operational environment. Yeah, and we did a lot of tabletop exercises. So not only did we do the flights, but we actually practiced them a lot in the full integrated chain, timing that, making sure that everyone knows what he's doing, and really to try to imagine what the future roles would be. And yeah, and I think that's where we learned a lot of valuable lessons, and that's also why I think our flights were safe. Yeah? Then we did, as to the assessment, okay, that's our main conclusion is that we need a lot more automation. Yeah? So with this project, we focused on the integration of everything, but I think what we still lack is automation of those interfaces. So this is one of the main recommendations that under our work package 5 we came up with. And then, oh, there's something went wrong. I pressed on the wrong button. So, and then work package 6. So basically, and I want to thank SGU for providing us the technical dissemination prize, 2 packs of beer. So we're very proud of that our communication was appreciated. We tried to disseminate it a lot. We did 3 conferences, an operational one, a technical one, and an executive one. We had a lot of the executive of both worlds, aviation, but also medical, come together. And in direct contact, I saw the, let's say, director of Red Cross talking to Maria from EASA. So I mean, this is the type of interaction we really want. Yeah? Yeah, well, ethics was addressed, typically an element that is a nuisance, but in a medical world, this is actually important, right? So this is also to be confirmed. Maybe then my pretty much last slide, and I see Jens is already getting up, so I have 2 minutes, right? So basically just to run over very shortly what we actually did. So actually, we were able to fly, and that's thanks to our project and collaboration, but also because we got some head start, right? So I have to admit that we had a previous project called Sapphire, so Sapphire Med is actually a sequel project, and we already on the 3rd of October 19, we did fly between hospitals in a city, but that was under national law, under very different setups. I think it was perfectly safe. At the same time, we did not use all the things like, U-space services, etc., because it simply did not really exist. We were developing that. But what we did do is we started writing our own procedures, and actually that's the reason why. So the legislation only came out afterwards, at the end of 2020, in place, in action. And so when we started working on Sapphire Med, we were able to already submit our full and complete submission for operational authorization already in April of 21, and we could never have done that if we would have had this head start, because it was a huge. I tell everyone it must now be a dead joke, but I always thought it was 400 pages. But here, Van Anderhoven, our operational head, he tells me it's 600 pages. So it's like pretty immense. But so that was a complete document that we submitted, and then of course we did some more technological things in parallel. So we did actually, for example, do 4 drones we had in parallel in the air, controlled from the C2C in a different location. So we had 1 drone in Germany, 2 in the Netherlands, different locations, 1 in Belgium, and they were all controlled by 1 C2C. And this was for us very important technologically, because we need to be able to have a fleet in the air and to maintain it, and also a drone agnostic fleet even, because there are multiple use cases we will need to operate. And then finally, on 17th of June, we got our operational authorization for the operator here, for BVLOS populated area flights, which is, I understood, the first one in the EU. And that was obtained. So we're all, as a team, very, very proud of that, of course. And also it's important that we show that, and we learned that we actually we basically got a confirmation that we understood the legislation. So that's, I think, the real thing that we learned. And then between June, September, we did then indeed execute flights, and that was specifically in Antwerp. We used and we put in practice, and we showed that indeed we could do that in a safe way. And now, of course, we have to build on that. So the cross-border regulation that's in place, Article 13, we have initiated based on this operational authorization, and others, by the way, that we also achieved. We want to transfer it to the Netherlands and to Germany. In the Netherlands, we have one now achieved. We're still fighting for, and then for the German one. And we hope that we did some tests, of course, in Germany, but not yet the way we want to do it. So in January, we hope that we can still feedback that we were indeed able to obtain the required operational authorizations also fully in the 2 other countries, that we can show still that one. And then, of course, the automated part, that is something that we still have to put in place. So we still really need to get mission ready. Yeah? So that's why we have, Maria, we've been collaborating on, so we've been working together with some other project members to get the future in place, to create proposals around the future, and actually there to use also the new legislation that will come out around U-space services, and to be able to use that from a rapid authorization level, which is basically what we will need in the medical environment. So thanks a lot for that.
Thank you, Michael, for this presentation. Then next project, I would like to invite on the scene a Tinder project coordinator, Sophie. She began her career as a military and obtained a degree in IT and communication. After 6 years, she continued her career as an IT project leader, civilian, and recently she turned to the aeronautical industry by leading this project, then Tinder. Then please, Sophie.
Thank you, Cengiz, for the presentation. First, I would like to present the Tinder project. So Tinder, what does it mean? It means tactical instrumental deconfliction and in-flight resolution. It was a 2 years project, and the main purpose of this project is to provide a complete solution of deconfliction. For that, we have a consortium of 11 companies from 4 different countries, Spain, France, Italy, and England. Innovatem was the coordinator of this project, and we've got innovative companies to help us on this project, such as Airbus Connect for all safety aspects, Collins Aerospace and Pilzo Labs that provide the hardware. Skybird U and Skyports provide the UAVs, but we also have some research institutions like Chira and Snova works about all the concept of operation and human factor assessment, because if you want to have a project successful, we need also to imply humans. We've got also Onera, which is a French institute research. They provide also the UAV, Technalia with the eVTOL that you can see behind you, and finally a competitiveness cluster, which is Aerospace Valley. So what is the objective of the Tinder project? As I mentioned, the Tinder project is to provide a complete solution of tactical deconfliction when a conflict is occurred in flight. For that, we've got a complete solution that involves hardware and software. We put inside the drones an air kit provided by the Pildo Labs, and also with Collins. Inside this box, we've got a radio, and we've got the same boxes on ground, and the 2 boxes discussed together through specific C2 links. And after that, it's help for the tracking of the drones, and it discusses with our tools in order to track all the drones in real time. For demonstration of our tactical deconfliction, we use 4 use cases. The first one is about when 2 drones fly in the same corridor, how we can, let's say, give the priority to one against the other one, and said, okay, a conflict is occurred, so how we can manage a conflict resolution and how we can send it directly to the pilots. The second one is about 2 different UAV in flight with delivery drones and an eVTOL. The same thing, who will have the priorities against the other. The third one is about let's say, two UAVs and 1 helicopter, because we know also that in the future we will have some helicopters around drones, so how we can deal with conflict resolution with an helicopter. And the third one, the last one, is about conflict resolution when an emergency appears, like a drone has a failure, hardware failure, for example, also a loss of communication. So for that, we perform 4 VLDs from July this year and September. And we use 6 UAV and 1 helicopters, the swoop from Skyports, the Air-44, which is the helicopters, the Vario from the Onera, the Matrix 600, and U-Miles and Sahara. For that, we improve our solution when the 2 Pildo boxes works together, discuss together. On the software, we saw the drones directly on the software, and when a conflict is occur, how we can manage the conflict. So a supervisor see the tools and say, okay, we have to choose a conflict, the resolution of conflict, and we've got 5 possibilities, which is the rerouting of the drones, the change of altitude, the change of speed, an holding point, but in this case, we have some difficulties to have an holding point because some drones are not able to do an holding point, so they have to perform an holding pattern. And for that, we have to implement that in our software in order to be able to perform the conflict resolution. And the last one is the return to home. So when, what I explained, an emergency is occur, a drone has a failure, a communication failure, a battery failure, something like that, and other drones fly around these other drones. So let's say we have to say, okay, we've got an emergency here, how we can deal with that? And for the other one, for the conflict resolution, for example, if we have speed changes, on the tools, we have the possibility to say, okay, at this point, you have to change your speed from this one to increase or decrease your speed, and for how many long and how many times. So on the software, we will see the future trajectory of the drones, and the protection volume of the drones will be smaller when the speed decreases. And from this point to the other point, the pilots will be able to see when he have to change his speed and what will be the next speeds of their drones. And after the conflict is solved. So this is what we perform during our 4 scenarios. We are very happy to improve our solution for the deconfliction part. It's the first step for this part. And the next is to be more autonomous, because at this stage, for the moment, we need a supervisor to click on the button and say, okay, we have to select this type of deconfliction. So for that, we also have some communication activity to spread the results and also what the project is talking about. So if you want to have more details about the project, don't hesitate to come to our booth, and I will be glad to explain more about that.
Thank you, Sophie, for the presentation. The next project, it's a project called U-space for UAM, which is also, again, a VLD. Will be presented by Jiri Iljic, who is with Honeywell Program Manager, Advanced Technologies Europe Consortium Coordinator, and he's the coordinator of this project. Please welcome to my colleague, Jiri.
Thank you, Cengiz, for your introduction. So, U-space for EM. U-space for EM project is constituted from 13 partners, from consortium of 13 partners. We have on board three ANSP, Czech ANSP, Austrocontrol, and NIRE. We have on board three aircraft manufacturers or vehicle manufacturers, Drone Hub, Lilium, and Vertical Aerospace. We have one USSP with us on a project Altitude Angel. We have 4 research institutions in a project, Technalia, Catec, RIDA, and DLLR, and one drone operator, Aviation. The consortium is led by Honeywell, who is providing the technologies enabling automated operations in the future. The main objectives of our projects were to mature technologies which support high level of automation for future deployment. We focus mainly on strategic and tactical conflict resolution, and we demonstrated also capability of the automated landing. We've demonstrated in 5 different flight campaigns, and by gaining the lessons learned from these demonstrations, we took it as a benefit for future development of our technologies, and also as a contribution to European CONOPS, which was led by CORSIX UAM project. The another aspect which is important for a deployment is the social acceptance. So we worked on identification of major opportunities and concerns of UAM deployment for general public. What were the results of our project? The main focus was on demonstration, as of all the other projects which were presented before. We did 5 exercises, 3 demonstrations of air taxi operations, and 2 demo campaigns of UAV demonstrations. First one was demo in Spain, led by Technalia, and during demo flights in Atlas, using the U-Miles vehicle, we demonstrated strategic and tactical conflict resolution with detect and avoid capability. That was the first thing. We also focus on other contingency scenarios like geofence zone, occurrence, and others. Second demo was demo with led by Vertical Aerospace. It took place in Bristol, UK, and we did end-to-end hardware-in-the-loop simulation, simulating the flight from very beginning when you request for a flight, through the checking of the vertiport availability, through the authorization of the flight and approval of the flight, by executing the flight by the pilot, and with the automatic landing capabilities in the end. So that was another demo which took place in Bristol, UK. Third demo which we did was a demo in Rzeszów, Poland, led by Drone Hub, and we wanted to demonstrate or show the business scenarios focused on automated monitoring of the area and AED delivery. The interesting in that particular demo was that there was a use of Drone Hub, which is the box which automatically charge the drone and taking care of the drone, so it can work automatically without any support from anybody else. Fourth demo which we did was the Aviation demo in Brno, Czech Republic, We did BVLOS flight in CTR of Brno City for a use case of like delivering between two laboratories, medical samples delivery between two places, and we demonstrated on that the contingency scenarios. We simulated during that real flight. We simulated geofence zone occurrence. We demonstrated like emergency landing. We demonstrated detect and avoid capability. For the fifth demo which we did was because obviously you cannot do all you want in a real flight. We did a simulated demo in Honeywell lab with our simulator, and what was interesting on the demo is that before we choose the trajectories to be flown, we talked to different stakeholders. We talked to cities, we talked to ANSPs, we talked to local CAAs to identify most viable or most meaningful like route for those flights. And once we agreed on those trajectories or those routes, we executed the flights with contingency scenarios. We found the alternative places for diversion in case of emergency. We demonstrated detect and avoid capability on that, and many others. But the project was not only about like demonstration itself. We also showed the integration with USSP provider, with Altitude Angel for most of those scenarios, and we verified in those real flights our technologies, their limits, limitations, and how those can be improved for a future deployment. We also provided lessons learned from the project, which obviously were quite significant. We provided that to ConOps coordination cell to get a benefit from our demonstration. And in order to be sure that we are going in a good direction, we did a survey with 6 countries involved and 3,000 respondents involved, and collected the feedback, as I mentioned, for what are the major concerns and opportunities for UAM deployment. These results will be available in a week, so you will have a chance either in our website or our social media to see what is the opinion of like normal people, what they think about the UAM UAV deployment. So that's a helicopter view on what we did in our project. We have a stand over there in the front of the stage, so I will be happy if you can visit us and see our videos. We have a simulated video with vertical. We have another videos, promo videos from the demonstration. So happy to see you there. Thank you.
Thank you, Jerry. Thank you for the 6 project coordinators. This is the end of the presentation. I will invite my colleague Robin for the next step of the journey.